In this video, let's talk about custom parameter constraints. So let's take an example. So I'm going to write a root template for the purpose of getting all of the employees under a certain position. So there are different ways to write it. For example, if I am targeting the employees, then I can start with employees and can say /employees /positions and /a position. So the last part is a root variable, or root parameter here. Of course, you can write it differently. For example, if we're targeting position, you can say /positions and then the position parameter and then /employees. So let me write it differently. Okay. So /positions /position parameter /employees. So both ways make sense. It depends on from which angle you're looking at it. Are you looking at employees or are you looking at positions? Okay. To me, the second way makes more sense. But since we have been targeting employees in this course so far, so let's use the first one. /employees /positions, and then last segment is the root parameter. Now, let's say that in the application that you are creating, you are only targeting two type of positions. So there's only two type of position makes sense. The first one is the manager, and the second one is developer. No other position makes sense. So which means that this position that is provided at the third segment here has to be either manager or developer. Of course, case insensitive. It doesn't have to be a uppercase M. So in this case, you can use a custom parameter constraint. Of course, you have to create it yourself. And in this video, I'm going to show you how to do that. But before we go ahead and working on creating a custom parameter constraint class, I want to emphasize that it is highly possible that you don't actually need to have this constraint. As long as you design your root template well. This is not necessary. You don't have to have a constraint here. Again, the constraint is mainly for the purpose of making your root template distinct. So as long as you have a good design with distinct literal part at the front, right? At the front, then you most likely don't need a custom parameter constraint. But for whatever reason, you just need it. Then here is how. First, let's go into Visual Studio here, and then let's create a class. You can come over here and create a folder, right? And then create a custom constraint under the folder if you have more than one constraint. But in this lesson, I'm going to just show you right here. I'm going to just create a class right here. I don't even need to create a public class because I'm going to just use it in this file. Right, so I'm going to call it position constraint. You can call it anything, but whatever you call it, the class has to implement the iRoot constraint interface. Now, to implement the interface, you do a control dot on your keyboard, or you can go over here and go to quick actions and then click on this. So control dot basically just opens the quick actions directly. So this is a shortcut, of keyboard shortcut. So I'm going to hit enter to implement the interface. And there's only one method that needs to be implemented, which returns a boolean, actually a function, not a method. And here, if the request matches the constraint, then you return true. Otherwise, you return false. So then how do you determine? In this function, you can see that the root key is passed in and the values dictionary is passed in. Of course, even the context object is passed in. So if you want to make more complex comparison, you can use this full HTTP context. But if you're just checking the root value, then you can use this and the values. Just these two are good enough for you. So let's try to use the root key and the values in this video. So we are using the requirement that the position has to be either manager or developer. So in order to do that, first of all, we need to check that we actually have the root key contained in the values dictionary. So if it's not there, we're going to say values dot contains key, right, and then root key. So if the values dictionary doesn't contain the root key, then we are going to just return false. Right? We're going to return false directly. Don't have to do anything else. Secondly, we want to see whether the root key, although it contains, it could be null, right? So if it's null, I'm going to also return false. Why it can be null? Because this values, if we look at this, you can see that why it can be null, because this is an object. It's not a string. So we want to be more careful. So we can use the second condition here. Now we can do string comparison. Right? Very simple string comparison. So if values root key toString object, you have to do toString equals manager, and I'm going to do string comparison ordinal ignore case. So if the root value that is passed in is manager, or if the root value that is passed in is developer, then we're going to return true. Okay, so the second one is developer. And in this case, what are we going to do? We are going to return true, not false. Otherwise, we're going to return false. Here's green squiggly line here. Actually, if we have done this, the green squiggly line shouldn't be showing here. And even though it's showing right now, I don't need to worry about it because, it's not null. So if this object is not null, it's going to have no problems to connect with dot to string. It's going to be converted to string. Whether it's equal to manager or developer, that's a different story, but our logic covers that. So I'm not worrying about the green squiggly line in this function. Okay, so now we have this class implemented. The next one is that we are going to try to use it. But before we use it, we need to register it as Python core. How do we do that? We use the builder object. So builder.services, and here we're going to add routing. And this one contains two different signatures. One, we're going to use the one with options in order to configure the routing. So here we're going to say options dot constraint map. We're going to add a constraint to the map. And first of all, I'm going to give it a key, which is the name of the constraint. You can call it position. I'm going to just call it POS, which stands for position. And then here I need to provide the type of the custom constraint that I just created. So what did I call it? Let me scroll down here. So position constraint, that's what I call it. So I'm going to say position constraint. And that's basically it. By doing this, I just added my position constraint to the constraint map, and then I can just use it. I can reference it by name. Okay, so let's add a get endpoint. Let me just copy and paste this first, paste it over here. Let me also try to maybe delete this, and then coming over here, we are going to change this to say get employees under position, and we're going to change this root. So it's going to be employees slash positions slash, and the root parameter, I'm going to call it position, and the constraint is POS. So this is the name that I just provided here, right? So I'm referencing this constraint by its name, or maybe it's called a key, right? Here it's called a key, but the key is actually the referring to the map. So you can just call it a name. I'm going to call it name. So this is the name of the constraint, and I'm using the name of the constraint to refer to that constraint. Then it's going to be used here. And here I'm going to say get employees and their position, and we are going to reference the position root parameter value here. I'm going to display that right here. Okay, I think we did everything, and we can give it a try. I'm going to copy this in my clipboard, and then I'm going to run it. Okay, so I'm going to paste whatever I have in the clipboard. And now here I know that value should be manager or developer, but if I just type in dev, then what I'm gonna get is 404. Remember, that's the correct response, right? So if the constraint is not satisfied, it is like it doesn't find the root template. Therefore, it goes to the not found 404 dummy page. So what if I go to developer? Now it got a match. So we're seeing this correct message here. And if I go to manager, of course, I see the correct response. But if I say manager of HR, hit enter, I go to 404, right? And if I just run it, right, with debug mode, and I'm going to do the same test. So go to manager. Now we can see that we have the root key position and we have the root values, which contains only one, and that is for position, and the value is manager. Right? So our logic and comparison here will definitely work here. Because it's manager, therefore it's going to satisfy this condition and it's going to return true, exactly returning true right now. And we'll go running that, we'll get the correct response. And if we do anything else, let's go here, we are not going to satisfy this, it's going to return false. And therefore, we're seeing the 4. Again, like I said, if we can design this well enough, we don't need to really worry about validating this, the constraint, because the URL in your application is generated by yourself. Right? You are not going to put a URL in your application that doesn't actually exist, doesn't lead to any page. You as a developer have control over which URL the user is going to click on, unless the user wants to enter the URL by themselves. In that case, if they enter something like 000, which doesn't work, that's a user error, right? You don't actually need a constraint to check that. So that's why I'm saying that usually you don't need a constraint, especially custom constraint. It's really used. But in case you need to use it, you need to follow 3 steps. First of all, you need to create a class that implements the iRoot constraint. Secondly, you register it right here. Very simple stuff. Give it a name. And then you reference the name and use it as a normal constraint, just like integer, date time, or whatever. You use it, a constraint. And that's it. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one.